process of losing an electron by an atom. If a substance loses electron, we call that substance is oxidized, right? And reduction is the opposite, which is gaining of electrons. It's a gaining of electrons. The process of gaining of electrons is said to be reduction. So we have some example here. In the following reaction indicate which is oxidized and which is radial. So how do we know which element is oxidized? For example, we have a combination reaction here. There is also oxidation reduction reaction. That means one substance has to be oxidized and the other substance has to be reduced, right? So can we make some prediction which element is oxidized? Which element do you think is oxidized? Is lithium or fluorine? Lithium is oxidized. Okay. Why is lithium oxidized? Okay. It's what? It lost 2 electrons. How do we know it lost 2 electrons?
Fluorine, the charge of fluorine is -1. There are 2 fluorine atoms.
Yes, yes. Also, we have to make a fact that fluorine is a non-metal. Non-metals are pretty much they gain electron. Metals are they lose electrons. So lithium is a metal. It has to lose electrons to react with the fluorine, because fluorine is a non-metal. It's the one that gains electron. So any process that relates with loss of electrons is said to be oxidized. And also, maybe we can make a little bit, we can go a little bit detailed that how many electrons is lost by lithium. Okay. So this number is also has something to do with the number of electrons lost by lithium. As you know, lithium is alkali metal. Lithium is group 1. Group 1 elements always lose 1 electrons, right? But since you have 2 lithium here, obviously we can say that 2 electrons are lost. The number of electrons lost by lithium in this reaction is not 1, but it is 2, and fluorine also gains 2 electrons. So the number, the coefficient here, makes a contribution how many electrons lost by a metal and how many electrons gained by a non-metal. Okay, the same situation we have here. We have iron and we have bromine. So again, which element is oxidized here?
Iron.
Iron is oxidized and bromine is reduced. Now the question is, how many electrons is lost by iron? How many electrons is lost by iron? 6 electrons lost by iron. How do we know there are 6 electrons lost by iron? How do we know that?
That's iron 3.
How do we know that's iron 3? Okay, is everybody clear with that? Because we have the 3 here, that means iron lost 3 electrons, but since we have 2 atoms of iron, 2 times 3 is going to be 6. 6 electrons lost by iron and 6 electrons gained by bromine. 2 times 3 is 6, okay? So always the number of electrons lost by a metal has to be the same the number of electrons gained by the non-metal. They have to be balanced. That's how a redox reaction is defined. Okay, now we're going to look something about oxidation number. Okay, oxidation number is actually it is a hypothetical charge that is presented on the ions of the compound. The charge on the ion. It is a hypothetical charge that atom would have if it was an ion. Now sometimes, oxidation number is considered to be as an accountant. It's like an account, or it's a way of tracking the electrons. How many electrons by loss by an atom, how many electrons by gain by an atom. But it's not, in some cases, it's not the same as the charge of the ion. Okay? It is a number that you put on an ion in a compound, but it is a number that you can track the number of electrons, not necessarily the same as the charge of the ion. So there are certain rules we can assign here to identify the oxidation number of an ion. If the atom is in its elemental form, the oxidation number is always 0. Now, if you see the atom in its elemental form, that means if it doesn't combine with any other element, there's no combination, it's always the oxidation number is going to be 0. Okay? So there's no any combination here. It's 0. If you have a monoatomic ion, what are monoatomic ion from our chapter 2, I believe, chapter 2 lesson, monoatomic ion, what are they?
Helium.
I'm sorry?
Helium.
Helium. Okay. A monoatomic ion are single atoms, right? These are the single atoms. The charge on the ion is the same as the oxidation state. Like, for example, you take magnesium. Magnesium is a monoatomic ion, right? What is the charge of magnesium? Magnesium has a charge of +2 because this is in group 2. At the same time, its oxidation number is always +2. Okay, it's always 2. Okay, before I go to practice exercise, I think there are other rules that we need to know here, and then I'll go back with this slide. Non-metals usually have a negative oxidation numbers. The oxidation numbers of non-metals is negative numbers. The oxidation number of oxygen is usually a -2. Oxidation number is -2. But in some instances, in some cases, the oxidation number will have a -1. For example, if you have hydrogen peroxide, that's a very unique case. And hydrogen peroxide, because hydrogen peroxide has a formula of H2O2, so its oxidation number is -1. A little bit different is the oxidation number of hydrogen. Hydrogen has a +1 oxidation number when it's bonded to non-metals. When it's bonded to non-metals. And hydrogen also have a charge of -1 when it's bonded to metals. That means you may have a situation that NaH, for example, NaH. What is NaH? Sodium hydride, right? In sodium hydride, what will be the oxidation number of hydrogen? -1. Because you have oxidation number of hydrogen is going to be -1 when it's bonded to what? Metals. For example, I have HF. What is HF? Hydrogen fluoride. Now, the oxidation number of hydrogen is going to be +1 because it's bonded with a non-metal. The other feature that we know about the oxidation number is that the sum of the oxidation numbers for the atom is going to be 0 for the molecule. If it's a molecular compound, the sum of the oxidation number for the atom is going to be 0 for a neutral molecule. A neutral molecule for a compound, in other words. What does that mean is, okay, I don't have it here, for example. Let me give you an example. You may have a situation H2SO4. Okay, it's a molecule, it's a compound, right? Now, we wanted to track the oxidation number of sulfur here. Okay, the oxidation number of sulfur here. Now, according to the rules of the oxidation number for oxygen and hydrogen, the oxygen has a charge of what is the oxidation number of oxygen? Is going to be -2. Okay, so oxidation number of oxygen is -2. There is only one situation that the oxidation number of oxygen is changing. Where is it at? In peroxide, in hydrogen peroxide. Other than that, the oxidation number is -2. Here, the oxidation number is going to be +1. Now, since this is a molecule, right, we don't know the oxidation number of sulfur. The oxidation number of sulfur. So what will be the oxidation number of sulfur? Is going to be +6. It's going to be +6. Okay, let's look here. The sum of the oxidation number for the atom in the charge on the molecule is going to be what? 0 for a neutral molecule. Sulfuric acid is a neutral molecule. It's not a charged ion, right? So the sum of the oxidation number of hydrogen, sulfur, oxygen has to give you what? 0. So 2 plus x minus 8 has to give you 0 because since it is a molecule, x is the oxidation number for sulfur, right? So it means this is going to be x minus 6 equals to 0, right? And we can isolate this. It's going to be x equals to what? Plus 6. X equals to plus 6. So the oxidation number of sulfur in sulfuric acid is going to be plus 6. Okay? Well, for example, what will be the oxidation number of sulfur in sulfate ion? What will be the oxidation number of sulfur in sulfate ion? In this regard, the sum of the oxidation number of all the ion has to be equals to not 0. It has to be the charge of the ion, which is minus 2. It's going to be 0 if it was what?
Neutral.
A molecule. It's a neutral molecule. So the oxidation number of this sulfur and oxygen added together, it gives you what?
Minus 2.
Minus 2. So that means let's say we don't know the oxidation number of sulfur. I'm going to put x, right? Okay. Minus 8 equals to what? Minus 2. Okay. 8 comes from oxygen because the oxidation number of oxygen is minus 2 times 4. This gives you minus 8. This gives you minus 8. And the 2 is the net charge, the net ionic charge. So that is the result right here.
So in every polyatomic ion, the sum is the charge of the.
Yes, the sum together, what we get is going to be the result of the net ionic charge. Okay, the net ionic charge. So in this case, for example, we have minus 2, so x will be minus 2 plus 8, right? When you do the mathematics, you move this minus 8 to the right side. So x is going to be what? Plus 6. That is the oxidation number for sulfur. And for example, we have PO4, 3 minus. PO4, 3, what is this? It's a polyatomic ion. What's the name of this ion? What's the name of the phosphate ion? So we wanted to know the oxidation number of phosphorus. We don't want to bother with oxygen because we know oxygen always have a charge of minus 2. The oxidation number is minus 2. So to find out the oxidation number of phosphorus, we will be x minus 8 equals to negative 3. Okay, so what is x will be?
5.
Minus 8, and you can just move minus 3 plus 8, and x will be plus 5. So that is the oxidation number of phosphorus in phosphate. Okay, I can have some example maybe can help you to understand a little bit more about the oxidation number of some ions. Let's go back here. See, the question is here, what is the oxidation state of the bold-faced element in each of the following? NaH. The bold-faced is hydrogen, right? What's the oxidation number?
Minus 1.
Minus 1. Why is minus 1?
Because sodium is metal.
Sodium is a metal. Sodium is a metal. When hydrogen is reacting with metal, the oxidation number is going to be minus 1. How about this compound, the oxidation number of sulfur? In sodium, what's the name of this compound?
Sodium sulfide.
Sodium sulfide. Yes, sodium sulfide. So what's the oxidation number of sulfur? I'm sorry? Plus 5. Okay. Okay. Anybody has a different answer? Okay. 4 plus 4.
Yes,
Plus 4. Plus 4. Okay. About about the others? What do you think? It is +4. It is going to be +4. Okay? How do we know that's +4? Again, we're going to make like we have Na2SO3. This is a monatomic ion, so the charge of sodium is going to be what? I mean, the oxidation number of sodium is going to be the same as its oxidation number. You need to read the rules of oxidation numbers. Monatomic ion have the charge of the monatomic ion is the same as their oxidation number.
Even if it's in combined state?
Yes. Yes, if it is in combined state. If it is in neutral state, it's going to be 0. Okay? So in this case, this is a monatomic ion, so it's going to be +1. Okay? Oxygen is going to be -2, right? Sulfur is going to be X, because that's what we're looking for phased element, sulfur, right? So since it is a compound, everything has to be added, and then you get what? 0. So 2 plus X minus 6 equals to 0, right? So that means X minus 4 equals to 0. We can isolate X by adding 4 here. X is what? +4. That's what it is. Okay? X is +4. How about here? So oxidation number of tin bromide. Tin for bromide. Tin is a transition metal. Its oxidation number is going to be +4. Okay? It's going to be +4.
I thought you said it's only for monatomic ions that the oxidation number is the charge.
Yes.
So is tin and the monatomic ion?
No. Tin is a transition metal. But again, because since I'm going to predict by putting X into it, but I know this is a monatomic ion, bromine, the charge is going to be changed. It's -4. Right? Okay, so X minus 4 equals to 0. Then X equals to +4. Okay, sometimes the oxidation. I'm sorry?
Bromine, what's the type of bromine? -1.
-1.
So, oh,
Yes,
okay.
yes. You have -1 times 4 is going to be -4. Since it is a molecule, this element, whichever is the element, which is X, I would say, X plus this gives me 0. Right? And then I can calculate that. How about here? What is the oxidation number of sulfate? Sulfate. I mean sulfur in sulfate ion.
Oh, 6.
Okay, this is going to be X again, right? In this case, the way that we calculate is since it's a monatomic ion, X 4 times -2 is going to be -8, gives me -2. Okay, because the net ionic charge is not a neutral molecule.
6 plus 6.
Yes, it's going to be X equals to -2 plus 8, X equals to +6. Okay. For Friday, yes, it's very important again, and I'm not going to ask you to memorize all this here. No, I didn't say that. But let me show you some trick. What you need to do is look the element, the first 5 elements on the top, and the last 5 elements on the bottom. What do you see? What is the common things that you see on the first 5 elements? They are members of what? Group 1 metals, and group 2, some of them are group 2. Lithium, potassium, barium, calcium, sodium, magnesium. These are group 1A and group 2A, pretty much. If you look the last 5 elements, the least one, are what kind of metals are they? Transition metals. And on the top of that, there are noble metals as well. Copper, silver, mercury, platinum, gold. These are expensive metals, right? Precious metals, we can say. What it means is that this is the way that the ease of oxidation will be increases. as I have said repeatedly, that when there is a chemical reactions, metals lose electrons, non-metals gain electrons. But what happens if you have two metals come to the picture? You know, some metals are easily lose electrons. Some metals are resisting to lose electrons. They don't want to lose electrons per se. Okay, like for example, you put sodium, a slice of sodium, a piece of sodium metal in water. It doesn't matter whether it's cold or hot. You can see the reaction right away. You can see splitting. You can see some kinds of fire or explosion. It's a very fast reaction. Put your gold on water. You never see any reaction, right? There's no reaction. Metal with water, it depends on what kind of metal you have. That means the reaction is a process of oxidation also. Metals lose electrons, non-metals gain electrons. What can we see? That there are metals which are resisting to lose electrons. And there are metals which can easily to lose electrons. So this is called the oxidation reaction. This is called the activity series of metals. You know, we have a list of metals. And in this list of metals, there are some metals which are very reactive, which are very easily be oxidized, which can easily be corroded, for example. There are metals, they are not be corroded, they are not easily be oxidized, so they are expensive actually. They can be stay for a long time, 10 years, 15 years, 20 years, okay? These are precious metals, noble metals. Okay, oxidation is reaction, by the way. So we're going to actually, what I'm trying to tell you that I don't want you to memorize all of them, but at least see the first 5 or 6 and the last 5 or 6, and then we can apply these on reactions. Okay, I'm going to give you a compound that's made from magnesium or aluminum versus with a compound that's made from copper, and see which of the element is oxidized and which of the element is reduced. Okay, that you can tell by looking up the activity series of metal. So try to just remember for the first 5 and the last 5, and I can continue from there on Thursday. Okay, I mean on Friday. Sorry.